This video is about quadratic equations and quadratic functions. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are constants and a is not equal to 0. A quadratic function, on the other hand, is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are constants and a is not equal to 0. While the definitions are seemingly similar, quadratic equations and quadratic functions are not the same, and it's crucial that we differentiate between the two. Let's start with quadratic equations, and a way to solve quadratic equations by completing the square. The quadratic equation ax squared plus bx plus c equals 0 can be solved by completing the square as follows. Step 1, you factor out the coefficient a of x squared. Next, you look at the coefficient of x. That's b over a. You multiply it by 1/2 to get b over 2a, and then you square the result. b over 2a squared, that's b squared over 4a squared. After you do that, we add, then subtract b squared over 4a squared from the left-hand side. When we do that, the first three terms give us a perfect square, specifically x plus b over 2a all squared. We continue with the algebra to get x plus b over 2a squared equals b squared minus 4ac, all divided by 4a squared. At this point here, we square root both sides to get our final solutions. X equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. These are the solutions of the quadratic equation ax squared plus bx plus c equals 0. Let's see some examples of completing the square. We'll work out the 3 examples on the screen step by step. Starting with the first example, let's solve the equation 3x squared minus 5x plus 2 equals 0 by completing the square. Start out by factoring the coefficient of x squared. So we pull out a 3 to be left with x squared minus 5 over 3x plus 2 over 3 equals 0. Next, I'm going to look at 5 over 3. I'm going to multiply it by 1/2 and square the result. So, I'm going to do this on the side. 5 over 3 times 1/2, that is 5 over 6. And squaring 5 over 6 gives 25 over 36. So I'm going to add and subtract 25 over 36 on the left-hand side. That's 3 x squared minus 5 over 3x plus 25 over 36 minus 25 over 36 plus 2 over 3, which I can write as a fraction over 36 as 24 over 36. all equals 0. Because we completed the square, because we followed the recipe of completing the square, our first three terms are going to give us a perfect square, which is x minus 5 over 6 squared. Minus 25 over 36 plus 24 over 36, that's minus 1 over 36 equals 0. Let's distribute the 3 to get 3. X minus 5 over 6 squared. 3 times minus 1 over 36, that's minus 1 over 12 equals 0. 3 x minus 5 over 6 squared equals 1 over 12, which means x minus 5 over 6 squared equals 1 over 36. Let us square root both sides to get x minus 5 over 6 equals plus or minus square root of 1 over 36, that's 1 over 6. Add 5 over 6 to both sides to get x equals 5 over 6 plus or minus 1 over 6. Our first solution is x equals 5 plus 1 over 6, that's 6 over 6, which equals 1, or x equals 5 minus 1 over 6, that's 4 over 6, which reduces to 2/3. So 1 or 2 over 3 are the solutions to the given quadratic equation. Example 2, let's solve the equation x squared minus x minus 1 equals 0 by completing the square. Usually we factor the coefficient of x squared, but in this case it's 1, so if we factor it we get the same thing. So we move on to step 2. We look at 1, which is the coefficient of x, well, the absolute value of the coefficient of x. We multiply it by 1/2 to get 1/2, and we square the result to get 1 over 4. I'm going to add and subtract 1 over 4 on the left-hand side. So x squared minus x plus 1 over 4 minus 1 over 4 minus 1 equals 0. The first three terms are going to give us a perfect square, specifically x minus 1/2 squared minus 1 over 4 minus 1, which I'm going to write as 4 over 4, all equals 0. X minus 1/2 squared minus 5 over 4 equals 0. X minus 1/2 squared equals 5 over 4. Square root both sides to get x minus 1/2 equals plus or minus square root of 5 over 4. That's equivalent to square root of 5 over 2. Add 1/2 to both sides. We have 1/2 plus or minus square root of 5 over 2. So x is 1 plus square root of 5 over 2, or x is 1 minus square root of 5 over 2. Example 3. Let's solve the equation 3x squared minus 6x plus 6 equals 0 by completing this square. First, we factor the coefficient of x squared, that's 3. We're left with x squared minus 2x plus 2 equals 0. Now we look at 2. We multiply it by 1/2 to get 1. And we square 1 to get 1. We're going to add and subtract 1 on the left-hand side. So 3 times x squared minus 2x plus 1 minus 1 plus 2 equals 0. As usual, the first 3 terms are going to give us a perfect square, specifically x minus 1 all squared. And minus 1 plus 2 equals plus 1. All equals 0. Distribute the 3 to get 3x minus 1 quantity squared plus 3 equals 0. 3x minus 1 quantity squared equals negative 3. We can divide both sides of this equation by 3 to get x minus 1 squared equals negative 1. And recall that negative 1 is equal to I squared. The complex number I is the square root of negative 1, so I squared equals negative 1. Let's square root both sides to get x minus 1 equals plus or minus the square root of I squared, which is I, and add 1 to both sides. We get x equals 1 plus or minus I. So our solutions are x equals 1 minus I, or x equals 1 plus I. Now let's talk about the quadratic formula. The quadratic formula is just an efficient way of solving quadratic equations. You can think of it as a shortcut to completing the square. So instead of doing all of the work of completing the square, one can use the quadratic formula. If you remember what the solutions are, according to these equations, you can simply figure out a, b, and c, plug them accordingly into the quadratic formula to find the solutions of ax squared plus bx plus c equals 0. Here are some examples. I'm going to work the same examples that I did with completing the square, but this time I'm going to use the quadratic formula. Here's the first example. Let's solve using the quadratic formula. 3x squared minus 5x plus 2 equals 0. Start out by figuring out what a, b, and c are. So a is 3, b is negative 5, and c is 2. The quadratic formula is given by x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's plug everything in. That's minus 5 plus or minus the square root of b squared, that's minus 5 squared, minus 4 times a, that's 3, times c, which is 2. All divided by 2 times 3. Minus 5 is 5, plus or minus the square root of 25 minus 4 times 3 times 2, that's 24. So we simply have 1 under the square root, divided by 6. That's equal to 5 plus or minus 1 divided by 6. This yields two solutions. 5 plus 1 over 6, which is 6 over 6, which is 1, or 5 minus 1 over 6, which is 4 over 6, which is 2/3. Notice these are the same solutions we got by completing the square. Example 2, let's solve x squared minus x minus 1 equals 0 using the quadratic formula. So a is 1, b is negative 1, and c is negative 1 as well. X equals minus b plus or minus square root b squared minus 4ac over 2a. Plug everything in. Minus 1 plus or minus square root minus 1 squared minus 4 times a, that's 1, times c, which is negative 1. All divided by 2a, that's 2 times 1. That's equal to minus 1, which is 1, plus or minus square root of minus 1 squared, which is 1, times minus 4 times 1 times minus 1, which is 4. 4 plus 1 is 5, so we have square root of 5, all divided by 2. And these are the solutions to our quadratic equation. Example 3. Solve 3x squared minus 6x plus 6 equals 0 using the quadratic formula. So a is 3, b is minus 6, and c is 6. The quadratic formula says that x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. That's equal minus 6 plus or minus square root of minus 6 squared minus 4 times 3 times 6, all divided by 2 times 3. That's equal to 6 plus or minus 36 minus 4 times 3 times 6, that's 72, all divided by 6. That's equal to 6 plus or minus square root of minus 36. 36 minus 72 is minus 36, all divided by 6. That's equal to 6 plus or minus 36 I can write as 6 squared, and minus 1 I can write as I squared. All divided by 6, that's equal to 6 plus or minus 6i divided by 6, which reduces to 1 plus or minus I. These are the solutions to the given quadratic equation. Finally, I'm going to go over some facts about quadratic functions. These facts will be especially useful for graphing quadratic functions. So for a quadratic function f of x equals ax squared plus bx plus c, the domain will always be minus infinity to infinity. In other words, quadratic functions are defined for all real numbers. Fact number 2 tells us that the graph of any quadratic function is a parabola that either opens up or down, as illustrated on the right-hand side of the screen. If a is bigger than 0, then the parabola opens up, and if a is smaller than 0, the parabola opens down. A is the coefficient of x squared. Fact number 3 tells us that the lowest point on a parabola that opens up is called the vertex, and the highest point on a parabola that opens down is also called the vertex. And the vertex can be found using the vertex formula, which tells us that the x-coordinate of the vertex is minus b over 2a, and the y-coordinate of the vertex is f of minus b over 2a. Fact number 4 tells us how to find the intersections of the parabola and the x-axis. These are the x-intercepts. Well, these can be found by solving the equation ax squared plus bx plus c equals 0. That's a quadratic equation that can be solved using the quadratic formula. Finally, fact number 5, the y-intercept, which is the intersection of the parabola and the y-axis, is always given by the point 0, c. Let's see some examples of graphing quadratic function. I'm going to go over the following 2 examples step by step. Starting with the first example, let's graph the quadratic function minus x squared plus 4x minus 4. Well, this is a quadratic function. The graph must be a parabola. And since the coefficient of x squared is negative 1, is negative, so since a equals negative 1 is less than 0, the parabola opens down. That's the first piece of information that's going to be useful for us to graph our quadratic function. Next, let's find the vertex. the x-coordinate of the vertex is minus b over 2a, that is minus 4 over 2 times negative 1, which is equal to 2. The y-coordinate of the vertex is g of minus b over 2a, which we found to be 2. So g of 2, we find that by plugging in 2 for x. That's minus 2 squared plus 4 times 2 minus 4, which is equal to minus 4 plus 8 minus 4, which equals 0. So our vertex is given by the point 2, 0. Next, let's find the y-intercept. We saw that that's given by the point 0, c. That's 0, and c is negative 4. So 0 minus 4 is our y-intercept. Now let's find the x-intercepts. This is where the parabola intersects the x-axis. To do that, we solve the equation minus x squared plus 4x minus 4 equals 0. That's minus x squared minus 4x plus 4 equals 0. We can solve this quadratic equation using the quadratic formula, but an easier way is to notice that the last expression on the left is equal to minus x minus 2 quantity squared. That's equal to 0, which tells us that x equals 2. And this tells us that the x-intercept is given by 2, 0. So, let's summarize what we found. We found that our parabola opens down. We found that the vertex of our parabola is the point 2, 0, which happens to be the same as the x-intercept. And we found that the y-intercept is the point 0 minus 4. Combining this information, we see that the graph looks like so. Notice 2, 0 is the x-intercept and the vertex of our parabola, which opens down, and the y-intercept is 0 minus 4. Moving on to example 2, let's graph the quadratic function f of x equals x squared minus 3x minus 4. This is a quadratic function, so the graph must be a parabola. Since the leading coefficient, meaning the coefficient of x squared equals 1, that's positive, the parabola opens up. Now let's find the vertex. The x-coordinate of the vertex is minus b over 2a. That is minus, b is minus 3. 2 times a is 1. And that's equal to 3 over 2, which equals 1.5. The y value of the vertex is equal to f of minus b over 2a, that's f of 3 over 2, which is equal to 3 over 2 squared minus 3 times 3 over 2 minus 4. That's equal to 9 over 4 minus 9 over 2, which I can write as 18 over 4, minus 4, which I can write as 16 over 4. That's equal to minus 34 plus 9 over 4. That's equal to minus 25 over 4, which is minus 6.25. So the vertex of our parabola is given by 1.5, that's the x-coordinate, and minus 6.25, that's the y-coordinate. Now let's find the y-intercept. The y-intercept is given by the point 0c, which is 0 minus 4. Next, let's find the x-intercepts. Those can be found by solving the equation x squared minus 3x minus 4 equals 0. Notice that a is 1, b is minus 3, and c is minus 4. So let's use the quadratic formula. X equals minus b, that's minus minus 3, minus, plus or minus, the square root of b squared minus 4ac, that's minus 3 squared, minus 4 times 1 times minus 4. All divided by 2a, which is 2 times 1. That's equal to 3 plus or minus 3 squared, that's 9, and minus 4 times 1 times minus 4, that's 16. 9 plus 16 is 25, and square root of 25 is 5. All divided by 2. This gives us 3 plus 5 over 2, which is 4, or 3 minus 5 over 2, which is minus 2 over 2, that's minus 1. So the x-intercepts, these are 4, 0, and minus 1, 0. So to recap, the parabola opens up, the vertex is at the point 1.5 minus 6.25, the y-intercept is at the point 0 minus 4, and the x-intercepts are the points 4, 0 and minus 1, 0. Combining all of this information together, the graph of f of x equals x squared minus 3x minus 4 looks like so. Notice where the vertex is at 1.5 minus 6.25. the point of intersection of the y-axis and the parabola, or the y-intercept, is at 0, -4, and the points of intersection of the x-axis and the parabola are at -1, 0, and 4, 0. And as you can see, the parabola opens